Hey guys, in this video we will talk about acceleration. It is the fifth and the final of the kinematic variables that we need in our study of kinematics. So we will take a look at its definitions and then some of the finer points about acceleration, and then we will look at some examples. So how is acceleration defined in physics? So we define acceleration as the rate, that means we will divide by time, rate of change in velocity. Important point to note here is it is the rate of change in velocity. It is not the rate of velocity. If I write it in terms of a formula, we will get A equals to the change in velocity upon the time taken. Oftentimes you will see people write acceleration A equals to velocity upon time. This is not correct. This is wrong. Acceleration is equal to the change in velocity upon time. If we write a formula for this, we will say A equals to delta V, that is the change in velocity upon delta t. And since you know that velocity is a vector quantity, we draw an arrow over here, and a similar arrow is drawn on acceleration to indicate that acceleration is also a vector quantity. Now if you remember the video on velocity and speed, I told you that there are two kinds of velocities, the average and instantaneous. Similarly, acceleration is also of two kinds, and the one we see here is the average acceleration because the time interval is large. So if we make the time interval small, then we write A equals to small change in velocity, that is dv, upon small change in time, dt. And this formula is the formula for instantaneous acceleration. And from now on, whenever we talk about acceleration, what we mean is the instantaneous acceleration or the acceleration at this instant. So let's see some of the important points regarding acceleration now. We just discussed that acceleration is a vector quantity. So it will have a direction. Then point number 2 is its SI unit is equal to meter per second squared, and that is easy to see because the unit of velocity is meter per second, and if you divide it by time, then you divide it by a second, and that gives you meter per second squared. Acceleration tells us how fast the velocity is changing. So when a body is speeding up, that is its velocity is increasing, we take the acceleration to be positive, and if the magnitude of its velocity is decreasing, then we say that the acceleration of the body is negative. And the term that we use for negative acceleration is deceleration. So we just defined acceleration as the change in velocity upon the change in time. Let's see what this equation tells us. If I say acceleration is equal to 0 means velocity equal to 0. Is this true or false? So look at the equation, that is the definition of acceleration, and you can say that A is equal to 0 means dv equal to 0. Now dv is not velocity, it is the change in velocity, and therefore the final velocity minus the initial velocity will be equal to 0, and that gives us the final velocity will be equal to the initial velocity. And so If the object is moving, acceleration equal to 0 does not mean velocity equal to 0. What it actually means is that the velocity will be constant. Okay? And if the object was at rest, then since initial velocity equal to 0, so it will be at rest. Let's ask the question in the reverse order. Does v equal to 0, that is velocity equal to 0, mean that acceleration equal to 0? Once again, the answer is not always. Because if the particle was always at rest, v equal to 0, then a equal to 0. But v equal to 0 does not mean dv equal to 0. And therefore, a may or may not be 0. An example of this case is when you throw an object upwards. Let's say a ball that is going up. It always has an acceleration g downwards, how we will see in later videos. So this ball is going upwards, and at the topmost point it stops for an instant and then comes back. So here the velocity is 0, but the acceleration is g downwards. So velocity equal to 0 does not imply that acceleration must be 0. What are the other questions that we can ask with this equation in mind? We can ask, do acceleration and velocity have the same direction? Always? Well, once again, the answer to this question is not always. When they do have the same direction, the acceleration causes the increase in velocity, and when it is not in the direction of velocity, instead if it is opposite to it, then it will reduce the value of velocity. And if you look at the formula, a equals to dv upon dt, which clearly tells us that acceleration is in the direction of change of velocity. Okay, so guys, that's all about acceleration. Now we have discussed all the kinematic variables that we need to describe motion. So in the next video, I will talk about the equations of motion. See you in the next video.